This is AP Calculus 5.5 and 5.8 test review. In problem number 5, we have x times the square root of x plus 5. Now we did an example like this in our homework. This is one of those situations where when we try to determine what we're going to let u be, if we let u be x plus 5, the derivative of that is 1. If we let u be x, the derivative of that is 1. And so we run into this issue where the extra part of our integral is not part of the derivative of what we want u to be. But we did see an example of this, like I said, in our homework, where we have to do 2 substitutions here. So I am going to let u be x plus 5. Then my du dx, as I said, derivative of x is 1, derivative of 5 is 0. And so if I rearrange this, this would just be that du is equal to dx. So I have a substitution right here for my dx, that is du. And I know that this part of my function, the square root of x plus 5, is just going to be the square root of u, but I need a substitution for x. So I go back to what I let u be, and I solve that for x. So basically I just subtract 5 from both sides, and I get that x is equal to u minus 5. So that is what I put in for x. And so now here's what I want to integrate. And basically I just have to distribute this square root of u to the 2 terms in the parentheses, and I will create the type of function that's like a polynomial that we can integrate using the reverse power rule. So I will have the integral of, when I multiply square root of u times u, that's u to the 1/2 times u to the 1st. So that's going to give me u to the 3/2 power. Minus, and then square root of u times 5, that's just going to be 5u to the 1/2 power. All right, so now I am ready to integrate. The antiderivative of u to the 3/2 means that I'm going to have to add 1 to my exponent, so that will become 5/2. And then I'm going to need to multiply in front by the reciprocal of my exponent, so 2/5. And then in my second term, I will still have the negative 5. I have to add 1 to my exponent, so 1/2 plus 1 will make that 3/2. And then I have to multiply in front by the reciprocal, which is 2/3. Now this problem did start with limits of integration on my integral symbol, so I don't need a plus c, but I am going to need to evaluate this on my limits of integration. However, I'm still in terms of u, so right now I am going to switch back to x. So I will have 2/5 times, and then u was x plus 5 to the 5/2 power, minus, and then 5 times 2/3 is 10/3. And then x plus 5 to the 3/2 power, and I am evaluating this on the interval from 0 to 1. Okay, so now I'm going to go ahead and do that. So I'm just going to plug in 1, and I'm going to plug in 0. So I'm going to get 2/5 times 1 plus 5 to the 5/2 minus 10/3 times 1 plus 5 to the 3/2. All of that minus 2/5 times 0 plus 5 to the 5/2 minus 10/3 times 0 plus 5 to the 3/2 power. And then at this point, I just grabbed my calculator and, I simplified one more step first before I plugged it into my calculator. So I wrote this out as 2/5 times 6 to the 5/2 power minus 10/3 times 6 to the 3/2 power, minus 2/5 times 5 to the 5/2 power, and then plus 10/3 times 5 to the 3/2 power. And then typing that into your calculator, you should get 1.190, and this is rounded to 3 places past the decimal point. In problem number 6, this time we have an indefinite integral, and this means we're going to need our plus c. We have also seen something kind of like this before, right? Where we have this x over 1 plus 4x squared. Now, if it were just 1 over 1 plus 4x squared, then I would say, well, that kind of looks like inverse tangent, but the issue is that we do have that x in the numerator. So in this case, I want to do a u substitution where I am going to let u be 1 plus 4x squared. And then my du dx, derivative of 1 is 0. Derivative of 4x squared is going to be 8x. Now, I don't have the 8, but I do have the x dx, right? So I'm going to divide du by 8, and then I'm going to multiply x by the dx. So I know that I will be substituting in du over 8 for my x dx. And then if my u is 1 plus 4x squared, then I'm just going to have 1 over u times du over 8. So 1 over u is my 1 over 1 plus 4x squared, and then my x dx is my du divided by 8. And of course, since I'm dividing by 8, and that's just a coefficient, I can pull that in front of my integral as 1/8 times the integral of 1 over u du. And then I know that 1 over u, or 1 over x, whatever our variable is the derivative of natural log x. So the antiderivative of 1 over u is going to be natural log u. Now I do need those absolute value bars when I'm going backwards and I'm integrating. And then again, because I don't have limits of integration on this, I am going to need that plus c. And then the last step here would be, of course, to plug back in what we let x be equal to. So this will be 1/8 times the natural log of the absolute value of 1 plus 4x squared plus c. In problem number 7, okay, we have, first of all, that 5 in the numerator. That can just go in front of our integral. And we do have an indefinite integral, so we know we're going to need our plus c at the end. And then we have 1 over the square root of 1 minus 81x squared dx. Okay, now if you know your derivatives, you know that this kind of looks like the derivative of inverse sine. It's just that the derivative of inverse sine is 1 over the square root of 1 minus x squared. So the trick here is, can I somehow rewrite 81x squared as a term quantity being squared? And so I want to rewrite this as 1 over the square root of 1 minus, and then 81x squared is a perfect square. That's 9x times 9x. So if I write it like this, now it looks like the derivative of inverse sine, and it's pretty clear that I should let my u be 9x. So here's my u substitution. I'm going to let u equal 9x. Then my du dx would just be 9. And of course, oops, I'm sorry, I forgot my dx there on my integral. And I just want the dx, which means that I'm going to have to divide that du dx equation here by 9. So du divided by 9, and then I'm going to multiply by dx, is equal to my dx. Okay, so this part right here is going to be my du over 9. And then this part right here is going to be 1 over the square root of 1 minus u squared. And as I said before, that 1 over the square root of 1 minus u squared, that is the derivative of inverse sine. So its antiderivative is just going to be inverse sine of u. So this is going to be 5 times inverse sine of u. Oh, and I've got my, sorry, I should have divided by 9 here because of that du divided by 9. So I've really got 5/9 times inverse sine of u. And then I'm going to need a plus c. And of course, I want to plug my u back in for my final answer. So when I do that, I'm going to get 5/9 times the inverse sine of 9x plus c. For my final integration practice problem, you should note that number 8 looks a lot like number 6, except in number 6, our numerator was x, and in number 8, our numerator is -2. Okay, well, once again, we can always pull any numbers or any coefficients in front of our integral symbol. So if I do that, then this is going to look like -2 times the integral of 1 over 1 plus 4x squared dx. Okay, and now this one, because I don't have a variable in the numerator, now this one looks like the derivative of inverse tangent. I just have to rewrite that 4x squared as some quantity being squared. But I know that 4x squared comes from 2x times 2x, right? So I can rewrite this as -2 times the integral of 1 over 1 plus the quantity 2x squared dx. And since I've made this look like the derivative of inverse tangent, now I know that I want my u substitution to be 2x. So then my du dx is just going to be equal to 2. And since I just want dx here for my integral, when I substitute my u and my du in there, then I am going to divide du by 2 and multiply both sides by dx. So this is going to be du over 2. And this right here is going to be 1 over 1 plus u squared. And then, of course, since I've got du divided by 2, I'm going to pull that out in front of my integral. So then I'm going to have -2 over 2, which we know is -1, times 1 over 1 plus u squared du. And then when I integrate this, again, I don't have limits of integration, so I'm going to need my plus c here. I'm going to have that -1. -2 divided by 2 is -1. And then I know that 1 over 1 plus u squared is the derivative of inverse tangent. So the antiderivative of 1 over 1 plus u squared is going to be inverse tangent of u. And my last step, of course, is to plug in what we let u represent. So -1 times inverse tangent of 2x plus c is my final answer.